Presenting a tool Will Payne and I have been working on, the Pseudo-Spatial Chart Program. We've actually presented an alpha version of the same project before, but today I hope to show off a more robust version by way of talking through some data sets that show what working solely in relational space can really do. Basically, last year at NACIS, Will showed you all the toaster we've been working on. Today, a bunch of cool recipes for toast. For those of you who haven't seen this before, the project started as a kind of polemic to the GIS logics that have steamrolled over other kinds of geographic thought, in spite of our technical ability to reproduce it. With the Pseudo-Spatial Chart Program, we hope to make a proof of concept for an automated way to visualize space somewhere between geographic and networked relationships. Basically, we're asking, how do we visualize data where distance matters, but isn't the defining aspect of the dynamic? For example, if I'm talking about Los Angeles, San Francisco, and New York City, it's important to know that New York City is farther away, but not necessarily important to visualize exactly how many thousands of times farther. All of that sounds pretty fuzzy, but the result in the end was a relatively rigorous tool for customizing distance decay. Given the internet connection and the problems that we've already had, we're not going to do a live demo and push our luck. I promise it works. Check out the GitHub. But let's look at the program itself. So we built it in R Shiny and are relying heavily on ggplot to visualize. The program's default data set is this Indian remittance data. So I'm going to play a little bit of a video to give you an idea of what it looks like in the wild. So if we play with our internet, so we have this data as a default. If we play around with the distance, you can visualize it with simple lat long. Now pretend that we've basically made a customizable polar projection. So we're just choosing where you get to center on anything, and that's the way that we imagine the world. So for this particular example, you can see the curve of Africa over here. You can see North America up in the top. And if you can rework your brain to shape in terms of the one center point that you're interested in, that's the logic we're more or less working on. As far as the interface itself, notice we have ways to customize both the distance decay and the size of our circles themselves, as well as options for changing the different data columns relative to the same central point, and playing around with labels a little bit. Ultimately, we were hoping that this was going to be a designer-friendly tool, in that, no, we're not going to build a perfect label engine, and yes, there's always going to be some zhuzhing necessary in order to get things to work, but you can export to SVG and play around with it as much as you need to make the graphics that make sense for you. Yeah, in terms of further examples, we've been playing around with various other types of use cases. This one is based on some bike share data for the city of Austin. So all of the bike share docks and in and out data for each individual dock. We chose one relatively central node, and playing around with small multiples, we're able to see small differences between how the system is used in different directions. Now, it being real data, it's not always as exciting as we hoped it to be, but you can see some small differences over here in both data sets. If we were very committed to the bike share example, or just had a much larger data set, we might consider making small multiples of the same to and from data for every single node, rather than relatively arbitrarily picking one, as we did for this example. Next is Next, I'd like to talk a little bit more about how we actually are working on this distance decay. This is an example of a customer log of a small business in New Hampshire. And it looks like garbage right now. Everything is super close to the central node. But if I play around with it a little more, since, as we know from economic geography, that cliff in terms of decay is quite small in terms of who would use a business in a given area. So this is the case where a logarithmic decay function is actually really useful. So we're able to capture all of these crappy little towns all over New England without losing these outliers on the West Coast. Yes, it's important to catch everyone here, but I still want to know that every once in a while, someone from California or Washington State goes to my small business in suburban New Hampshire. This next data set is my personal favorite. We literally just got it last week. If anyone knows Taylor Shelton, he was kind enough to lend us his data set of the 10 largest landholders of residential property in Fulton County, Georgia. We plugged all of the data into the system and got some interesting insights on seats of power distant from the buildings themselves. So before we do anything, we need to emphasize where the local holdings are and how they would otherwise pile on top of each other unless we start customizing how we look at distance. Because it's such a small county or urban-based setting, that definition of what close is going to be quite small. So now I've created this projection or this idea of what a distance is, where I can really focus on what's close to the actual properties, but I can see these distant extra areas farther away. And if I start to mess around with the variables themselves, I can say, all right, in Georgia itself, the value is relatively equal to these outside holders. But if I move to an appraised value, I can see that a surprise, or the acreage rather, I can see that a surprising amount of land ownership is actually held by these corporate guys out in Texas, this hedge fund in New York, or some of these, whatever sketchy thing is happening in our tax haven of the US Virgin Islands. So in order to look through the data, we've messed around with distance a little bit and doing some data exploration, where suddenly these different narratives of different actors start to emerge with relatively little that we've actually done in terms of real analysis. We're being able to visually see some of the dynamics that are at play already. Moving on to a case that has been rather personal for me. Just as a side note, I live in Armenia. It's currently in the midst of a really brutal conflict, and one of the major criticisms of people on the ground is just the complete failure of the European diplomacy mechanisms that were meant to keep the peace. So we've built this program to be as not fussy with data as humanly possible, which has led to some some workflows that mean that I can basically use data that I would do for just a simple choropleth map with just a single extra column. All we need at the moment is to manually add a column that says, yes, this point is the center. But yeah, these comparative choropleth maps of multilateral organizations in which each of the stakeholders in the conflict are engaged. Give us an idea, give us an idea of membership and different geopolitical relationships with, I don't know, it was an hour on Wikipedia, making a bunch of binary lists of different organizations. But you notice, because of all of these fiddly little countries in the European organizations, I again had to create some sort of custom distance decay to be able to see all of the dynamics that are going on. I particularly like this case because there's
we're out of time.
There's a problem with visualizing data. Whoops.
I'm sorry to cut you off, Evangeline. It kills me to cut you off. This is fascinating, and I want to hear more. But we're out of time. Sorry about the blip early on. But there's actually a lot of really good conversation happening in the Slack channel about your talk and this tool. So thank you so much